In this video, we're continuing with Chapter 11. We're in a section 11.1 Part B, and we're talking about similar polygons, and we're going to look at example 3 in the notes packet here. So we want to determine the following information given that quad is similar to 5. So we're given that these two quadrilaterals are similar. And we can kind of see that they're in a nice orientation, so we know that Q and F are corresponding. We can see that by the similarity statement. Since they're both first in the similarity statement, we know that they're corresponding, and we know that D corresponds to E, so these two are corresponding, and so forth. So we can use our similarity statement to help us, but these are in matching orientation, so that's helpful as well. Alright, so for the first part here, we want to state the corresponding angle pairs and write a proportion that relates the corresponding side. So that's our statement of proportionality. That's what we're going to do here. Write a proportion, statement of proportionality. Alright, so we're just going to match up the angles. We know that angle Q is congruent to angle F. Angle U is congruent to angle I. Angle A is congruent to angle V. And then our last pair, angle D, is congruent to angle E. Alright, so remember, if figures are similar, their corresponding or matching angles are congruent. So that's what we did here. Okay, now we're going to write our statement of proportionality. So we're going to match up the sides. So I've got QU is to FI, so those are the matching sides here, as UA is to IV, which is to A, which equals AD to VE, and then our last one would be DQ to EF. Okay, that's our statement of proportionality. Now, since we were given the large figure first in the picture, and our similarity statement has the large figure first, we have the sides of the large quadrilateral in the numerator. We could have easily just switched everything as well. Alright, let's move on to the scale factor. So since they're similar, we can use any one of these ratios here in the proportionality statement. So we need to find a pair of sides that both have numbers on them. So I can see that there's a 6 over here and there's a 3 over here. And then all the other sides are missing one of them, so we're going to use that. So our scale factor is going to be 6 over 3, which simplifies to 2 over 1. And a lot of times we like to leave our scale factor as a fraction, and that's going to help us do calculations later. Alright, part C, we want to calculate x, y, and z. So this is where our scale factor comes in handy. So I know that the ratio of any pair of corresponding sides has to be 2 to 1. That's my scale factor. So let's start with x. So I'm going to start with my scale factor. 2 to 1 is equal to, alright, so let's see, what side has x on it? Let's get rid of some of this extraneous markings here. So here's my x, and I can see that that goes with the 8. So since I did 2 to 1, my next proportion, or my next ratio, is going to be 8 to x. So equals 8 to x, and then I'm going to cross multiply, so I get 2x is equal to 8, and then divide by 2, and I get x is equal to 4. Alright, now for y, I'm still going to use my 2 to 1, so I'm going to start with 2 to 1 is equal to, let's figure out where my y is. So here's my y, so that's going to go in the numerator, and it corresponds with the 5, so I'm going to have y over 5. Y over 5. Again, I'm going to cross multiply, so I get y is equal to 10. Alright, and then I need to find z still, so I'm going to use the same scale factor, 2 to 1. Let's go back to my picture and find out where my z is. So here's my z, and that corresponds with the 9. So remember, we did large over small, so when we go back down here, we're going to go 9 over z. Okay, large over small equals large over small. So we'll go ahead and cross multiply. I get 2z is equal to 9, divide by 2, and I get z is equal to 4.5. Alright, for the last part here, I want you to pause the video and see if you can find the ratio of the perimeter of quadrilateral quad to quadrilateral 5. So find the ratio of the perimeter. So pause the video now, and when we restart, the solution will be there so you can compare. Alright, so if you did this correctly, you would have gotten that the ratio of the perimeters turns out to be 2 to 1. And if we notice that this is the same as the scale factor. Okay, so we talked about that earlier before. But again, if figures are similar, the ratio of their perimeters is going to be the same as the scale factor. Alright, so that's the end of this video. If you have any questions, make sure you get those answered, and we'll see you next time.